All right, for number 2. 3 balloons are filled with the same number of atoms. Okay, now, so that means we have the same number of moles. Okay, same number of atoms. Now, at this point, what I would start off, what I would start off thinking is this. In my mind, I probably would have a picture. Okay, I would have maybe like 4 circles in it. And in my mind, I would be like, okay, so I have this, and I have this. Okay, they are helium, argon, and xenon. Oh, just 3 gases, even better. Just 3 gases. Okay, all right. Now, if I don't look at the choices, can you tell me among these 3 gases what would be the same and what would be different? Now, it says that they have same temperature and same pressure. So same P, and same T. Yes. They will have the same kinetic energy. Very good, because they have the same temperature. Since you brought up the kinetic energy, I would ask, would they travel at the same speed? Good. So same kinetic energy, but different speed. Okay. Density. Well, first, what's the definition of density? What's the definition of density? Mass divided by volume. Well, density, you can look at this as how spaced out, but you should also look at the the very definition of mass over volume. Okay. Well, spacing out is just how crowded something is, but density is mass over volume. Now, actually, can you tell something about the volume of these 3 gases? Would they have the same volume or different volume? How do you know they have the same volume? Well, it's actually all 3 together. If you look at PV and RT, same P, same T, same N, it's got to have the same V. So you have the same volume. Actually, that gives you the answer already. But yeah, let's prove how the other ones are not true. If you have the same volume, but different kinds of gases, then they will have different masses. And that's why the density of each gas will be different from each other.
Wait, hold on. So don't have same volume with different gases means different masses.
Correct.
Right.
It's just like you have 3. It's just like I separate 4 of us into 2 rooms. The density, well, I mean, how crowded the room will be the same. Yeah. But the density will be different because the masses of you 2 will be different with the masses of us 2. So I don't want you to think density as only about how crowded something is. It's also it's the very definition of mass over volume. That's density. It is, yeah, which is a definition. We define what density is because we care about how many grams over volume. Okay?